Math 3, Practice 4B.4.1, Linear, Exponential, and Quadratic Functions. So we've got a table here to answer the first three questions. Okay, and this has to do with the speed of Wi-Fi measured over distance. So now, the weird part about this is that how they say this. Okay, that this one is essentially, they're all like y-intercepts. So if we're graphing them, this would be up 450, 110, 50, something like that. Okay, and that would be those plotted points. Let's actually make that a different color. Okay, then we go and we have the distance, okay, which would be, they'd all be like x-intercepts. So it'd be like 18, 0, 55, 0, 91, 0. Okay, so that would be like, we have 91 here, 55 here, 18 here, and it would be 18 right here, 55 right here, and 91 right here. So it says if a line is drawn connecting the pairs of distances and speeds on a graph, what would the slope of that line represent? Well, so they'd want this line connected to that, this one with this one, and here connected to here, okay? So then it's asking, well, what does that have to do with? What would that slope be? Okay, the average rate of change. Well, we'd be going down on speed as we go up on distance. So we'd be connecting speed, right? It would be the Wi-Fi signal, which is in megabits per second, to distance, which would be per meter. So it would be Wi-Fi speed in megabits per second per meter. Now it says calculate those slopes. All right, well, to calculate them, we'd go down 450 and to the right. So this is for question 2, to the right 18. So it would be negative 450 over 18, which if we use a calculator for that, we would get 25. 25 over 1, so 25 megabits per second per meter, essentially. That's what it would mean in the context. For the blue one, we'd go down 110 and to the right 55. So negative 110 divided by 55, now it would be negative 2. This should have been a negative 25. So in the context of this one, we'd be going down 2 megabits for every meter. Okay, and then the last one we go down 50 and out 91. So it'd be negative 50 over 91 for the last one. Which would give us about 0.55, which 0.5 would be about negative 1/2. So negative 0.5, negative 1/2. Okay, we'd lose 1 megabit per every 2 meters. That's what it would mean according to the context of the problem. Okay, 3 says, which function model, exponential, linear, or quadratic, would best describe the relationship between distance and speed? I know we probably want to say that these would all look linear, and that's true, but we're kind of taking more how these slopes are changing, okay? And if we think about it, the further we get out, it's still going to eventually be able to reach there, so we'd probably never go to 0 or to negative. So this idea is, linear wouldn't work. Quadratic, so linear would mean, it either keeps going down until it gets to 0 or it keeps going up. Quadratic would be it would go down for a while, but then it would get faster the further we got away. We know it's not that. So an exponential probably would be the closest one, that it just never quite gets rid of it, but it gets really, 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 really slow the further out you get. Okay? All right, so for the rest of the problems, determine the type of function, exponential, linear, or quadratic, that is most appropriate To model the situation described, then use the chosen function model to complete the problem. So, a credit card company compounds annual interest daily. What is the domain for a calculation of the interest rate for 1 year that is not a leap year? So there'd be 365 days in a year. Anytime you're dealing with interest, that is definitely exponential. Okay. And what is the domain for a calculation of the interest rate for 1 year that is not a leap year? Well, you'd start from 1 until you got to 365. So it would go from 1 to 365. All right, 5. The school physical education program requires students to be timed for a 50-yard run. What is the range of the average student speeds? Okay, so for this one, we're dealing with a 50-yard run. What is the range of the average student speeds? Okay, well, speed is distance over time, right? The distance we know is 50 over time. So it would kind of depend. You know, I guess speed would be from like basically 0 miles, which probably slightly above, so I don't know if I'd include that. So it'd probably go from 0 to about 50 t, because we're talking about speed, how fast they're running, not how long it's taking them, because the range would be that speed. Okay, so it'd probably be from 0 till as fast as we were able to get, which with these students I don't know, but probably wouldn't go very fast. And I would say it's probably going to be a linear equation. Number 6, a bowler starts out with a league average of 160 points per game and then has an average of 164 and 166 points per game after the next 2 weeks respectively. What is the asymptote of the bowler's average if this trend continues and only whole numbers are used to express the average? Okay, well, it's got an asymptote. The only one with an asymptote is exponential. So we know it's got to be that. So where would it... So he starts out with a 160, then it goes up to 164, then 166. What if this trend continues and only whole numbers are used to express the average? This is a weird question. So we're saying we've got this exponential equation going on. We know you can't get higher than 300, right? So at some point, he's going to top out at y equals 300. So that's probably what I would go with. Is that's the ceiling. He can't go higher than that. Could he get to that? Yes. But I'm not sure where they want me to go with that. We'll call that good. Yeah. Not sure. These are kind of stupid questions, honestly, because they're not really giving us much math to do. But we'll try to finish them out. A magma bomb is a solid chunk of hot semi-solid rock ejected by an active volcano. What factors affect the height reached by the magma bomb? Assume that only the acceleration of gravity acts on the bomb once it is ejected. Okay, well, we're dealing with objects that are flying up and then back down, so it's definitely got to be a quadratic. Okay, what factors affect the height? Well, I would say the force, the acceleration, the velocity as it's spewed forth out of the volcano. that's going to really affect how high it goes and how long it stays up. That's probably what I would say would affect it the most. Let's move on. In baseball, batting averages are expressed as decimal parts of a whole. For example, a batting average of .300 is said to be a batting average of 300. A baseball player's original batting average of 250 decreased by 5 points per game during a 10-game slump. Describe the domain and range of a function that relates the batting average to the number of games. So we'd have the number of games and the batting average. So we've got 10 games here, essentially, in his slump. He started out at 250. It's going down by 5 each time, so 245, 240, 235, 230, 225, 220, and so on. I don't think I made my graph high enough, but you get the gist of it. Okay, so that's definitely going to be a linear, because it's changing at the same rate. Okay, we go from the first game, so the domain would be the first game to the 10th game in his slump. The range would be, he goes as high as 250, .250. Then we got to see how many times we go down. So that's 2, 4, 6. And we got to keep going. So 8 would be down to 210. So then .200. So .200 to .25 would be our range. And that one felt a little more mathy. Okay, 9. Meteorologists use the term Sacagawean screamer to refer to a fast-moving Arctic cold front originating near the province of Saskatchewan. Did I say Sacagawea? Wow. That's weird. I give up now. One day, such a cold front caused the temperature in Chicago, Illinois to drop from 30 to -5 in 3 hours. What are the domain and the temperature change and average temperature change per quarter hour? Okay, so we had the temperature. Okay, so we had 3 hours, so within 3 hours, so 1, 2, 3 hours, it went from 30 down to -5. So we began up here at 30. After 3 hours, we went down to -5. Okay. The domain would be 0 to 3. And this is actually for number 9. Okay. And then what would the temperature change be? Well, it would be -35 over 3. Per quarter hour, though. So if we're doing it per quarter hour, I've got to change that, right? Because that means this would be, we'd cut each of these into fourths. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'd need to divide that by 12. If we're going per quarter hour, because we have to cut each hour into fourths. So -35 divided by 12 would give us about an average rate of change of -2.92 degrees Fahrenheit. All right. The temperature change would be obviously -35 degrees. And we'll call that good on that one. All right, number 10, last one. Let's be done with this homework. The dimensions of a piece of paper used to wrap a rectangular package are x and 2x minus 1 inches. So we've got a piece of paper here. It's x and 2x minus 1. What is the function with the dimensions that result in the maximum area for the wrapping paper? Okay, well, area is length times width. X times 2x minus 1 would give us 2x squared minus x, which x squared means it's quadratic. And here would be our function. And there we go. If you were able to do any of this on your own, I am very proud of you guys, because this was some pretty interesting, weird ways of thinking through it. So, well, we are done though, so we'll call that good.